Welcome to the next session of Stronger, the evolving boardroom, CISOs, SEC rules, and the AI revolution. I did a variant of this presentation out in California about 2 months ago. The idea, I think you'll see as the presentation unfolds, is to present some of the challenges, the historical challenges we all face, some of where AI could, in theory, take us, with an emphasis on in theory, and basically how the SEC rules have maybe shifted the landscape a little bit. Let me advance here. So just by way of introduction, I'm Padraic O'Reilly. I'm the founder and chief innovation officer at CyberSaint. I worked in AI systems when I was younger. It was early big database stuff, trigger events analysis, early neural nets. And then I sort of shifted over to macroeconomic modeling. My background before I got into cyber was in, sort of finance and big financial models. So I bring a little bit of a different perspective to cyber. I was asked to look at the problem in cyber by a CISO. I'll be eternally grateful. Great friend of mine and the gentleman I started the company with. We used to surf together, and whenever we were surfing, he was very good. I was not very good. So I would be falling off the board, and he would sort of yell at me over the waves. You really have to take a look at cyber, and I poo-pooed him for years. I didn't think that I was going to find anything, but he was right. The problems in cybers, I've been sort of doing this for a decade, and it's been an absolutely fascinating ride. So what are we talking about? Where are we in cyber risk management 2024? I maintain that we're at a unique historical moment in cyber risk management. And I maintain that because of the confluence of regulatory developments, some of the advance of the APT and their affiliate structures, and AI sort of entering the scene full force as of last year, even though we were working with AI well before that. And many of our partners like IBM and others have been in AI for quite some time. But nonetheless, large language models have changed the conversation. There's a lot of data in cyber, as we all know. So there's a lot of brilliant open source work too. A lot of it has not been stitched together in a way that is repeatable and scalable and transferable to different environments. So think cloud, on-prem, different architectures as well. We have in cyber, and this is one of the first things that grabbed me, we have a balkanization of data. We have it across functions. We have it across corporations. We have it across, it's in public and private sector all over the place. And the data does not always play nice together. And that's a longstanding problem in data, the going way back. But there are some incentives that the private sector has faced to maybe keep their data, keep it close to their chest, or to make it unique. To create an ecosystem where, we sort of all bumble around blindly and come to be dependent on particular solutions. So, but I think most important of all, and this is the last bit on this slide, is the emerging consensus around CRQ. Gartner published a study not too long ago saying, many chief information security officers and other information security professionals had tried to implement a cyber risk quantification program, and they found it wanting, and they were sort of still casting around for something that worked. There's, a lot of reasons for that. Some of it is native to the products and offerings in the space. Some of it is also natural to the, stretch goal of doing financial modeling for those who are not, don't have a background in it. Some of it too has to do with the complexity of the model. So, but, this year it's become pretty clear that the mandate from the SEC, which is really, in essence, to bring governance closer into the discussion around cyber risk management and financialize that discussion, that there are certain metrics, tools, frameworks, standards that are in play for professionals to use and improve their communication, you know, and that's really what it's about. I was on a session this morning and we sort of ended with communication. So a lot of the problems in our space have not really yielded to human analytical brute force. And I'll talk a little bit about what I mean by that as the talk goes on, but with some help from new techniques, breakthroughs are possible. So I just got off a session with the deputy director of CISA, and he ended it with optimism around AI and improved use of data in our space, you know, strengthening critical infrastructure. So, all right. So what did the SEC rule really mean? A lot of people, you know, look at the sort of early enforcement actions and say, well, you know, it means that, you know, they're going to hold CISOs' feet to the fire a little bit, and it's been scary because in some ways there might be some, you know, legal implications for individuals, and they don't feel maybe properly indemnified. But I see it a little bit differently. I see the rules around you know, policies and procedures to identify and manage cybersecurity risks, management's role in implementing cybersecurity policies and procedures. You know, what is the role? Director's security expertise, if any, and the board's oversight of cybersecurity risk. I see all that as attempting to get into a set of incentives that existed on both sides and realign them. So for quite some time, we saw that information security officers had an incentive maybe to, you know, secure the organization, to do the best job they could with that, with limited budget, limited say-so in where that spend might go. So they had sort of maximal liability and minimal levers to pull on financially. That sets up an incentive structure where maybe disclosure is a little bit tricky when you're trying to communicate upstairs, or they may not have even asked for that advice and counsel. On the governance side, you had a set of incentives that really are very clear, you know, because they're fiduciaries. Anything they know about as a fiduciary, they're immediately responsible for, right? But they're indemnified for that. Nonetheless, the way IT culture and the corporate business culture grew up, and I was a part of this in the 90s and early aughts, was you stay over there on the IT technology side. You do what you do, but you know, don't trouble us with the details. That led to an unfortunate, I think, impasse between governance and information security. That's all changing, I think, because Gensler, being an economist, has weighed in. He's trying to change the incentives, and from my perspective, the incentives have to change, and the greater transparency can yield better outcomes. That's just economic theory. So if you've got an informational asymmetry, which is incentives to hide information or incentives to not want to know information, that leads to inefficient outcomes. And by that, I mean, you know, the accurate pricing of, you know, the equity share price or the value of the company if it's in the private markets. So that's how I see the SEC. And the expanding board role is really just making sure that governance has a role in the actual practice of cybersecurity. In our industry, it's really led to, you know, in software that does cyber risk management, it's led to a sea change in how certain organizations think about the practice of cyber. They did cyber, they do it well historically. They may have had a breach, and that leads to you know, a culture change in a sense. And that culture change is, can I talk about what I do as a chief information security officer or as a cybersecurity professional or as a risk officer? Can I talk about what I do and ground it in financial data? That is how we've approached it. We've approached cyber risk using actuarial data because that's how insurers do it too. So, you know, for us, it's very important to understand the practice of cyber financially, not just technically, but financially. I'll get into that a little bit as we go. All right, so here's the, you know, framing the problem 30,000 foot view. You got to 1,500 new malware variants per minute. This stuff, you're probably pretty familiar with some of this stuff. 20 to 30,000 vulnerabilities per year. Again, I was just talking to Dr. David Mussington. He was talking about the CISA key exploited vulnerabilities catalog. 4,000 attacks per day, 150 plus APT groups. There's not to mention all the affiliates who don't really even need to have the expertise in crafting malware and the like. They can just sort of plug and play. And then the social cost. You know, some estimates range from 1 to 10% of global GDP. It's very significant. And all surveys that take, you know, that query executives, they're asked about the top 2 or 3 existential risks that the organization faces. Cyber risk is 1 or 2, and that's just a fact of life now for all of us. So again, I sort of jumped the gun a little bit there on the SEC, but we need to do a better job, not just individually, you know, as companies, but we need to do a better job as a society, deciding how to spend the resource or allocate the resource to solve this problem and this challenge, because right now there are some inefficiencies. So I'll talk a little bit about that. This here is a picture of an individual in a monkey suit among some graduate students. Perhaps some of you are familiar with this little social experiment. It was Daniel Simon's. The idea was, you know, you were to watch the ball and watch the ball being passed, and you're told to just watch the ball being passed. And the sort of experiment runs through, and you're focused on watching the ball, and you don't notice the gorilla walking right through the middle of the graduate students. It's sort of illustrative of a particular problem in human perception, that we're often very focused on the problem at hand, and sometimes we miss the details. There's another research psychologist who was at Harvard in the 50s and 60s and maybe early 70s, George Miller, who you know, came into a psychology department that was heavily laden with behaviorists, you know, and B.F. Skinner and the like, and you know, they were teaching ping pong to pigeons, teaching birds how to play ping pong, you know, and it was a very reductive idea of human beings, that we were just input output machines and the like. Miller was more interested in perception and in memory, and he made the point that the human short-term memory can maybe keep 7 items in short-term store, plus or minus 2. So the Miller principle is 7 items plus or minus 2. So at the low end, 5 items can stay in the short-term memory store, and maybe 9 at the top end. So why is this relevant to cyber? Well, you know, we all deal with tremendous amounts of data on a daily basis. It changes. We're working across many frameworks. We're working across control standards. We're working across, say, MITRE ATT&CK. You know, we might be working with CAPEC. We might be working with likelihood and impact and risk models as well. And there's open source, all source intelligence. There's threat feeds. Day to day, the analysis challenge, it arguably can elude, you know, even the most energetic of human minds, right? So throwing more bodies maybe at this problem, well, we'd like to throw bodies, well-trained bodies at it. Throwing more bodies at it in the long run probably is not the solution. So we're basically using 2 dimensions for an n-dimensional solution. That's a problem. And we need to maybe change the paradigm. And I think in some ways we are. All right. So in cyber risk, in CRM, cyber risk management, and CRQ, we need to stop bringing our spreadsheets to a knife fight. You know, this is cyber risk management is an involved and complex challenge. It can be made simple, but there's a lot of discipline that goes into that. So how do I look at this? This is from an outsider coming into cyber. I saw all this brilliant research that was done in our field, right? There were great products, great endpoint products, great behavioral analytical products. There were, you know, great configuration management products, great products that had a lot of data stored about systems, about architectures, about humans, but none of this had been orchestrated into an entire picture, right? So, getting controls, say, automated, that's one aspect of the challenge, right? Getting controls and then checking to see how those controls are implemented. That's another challenge. So none of the great open source projects, and I don't mean to pick on the Verizon database, or Veris, but for example, that was a great going concern for a couple of years. And then, HIPAA didn't update, COVID came along, and they stopped updating the database to some extent. So, there are wonderful projects out of the government and government affiliates like MITRE, but it hasn't all been stitched together. These are analytical tools you can use. You can throw them in a spreadsheet. But how do you get a spreadsheet to adapt, on a daily basis? How do you do change management in a spreadsheet? The combinatorics get nightmarish. This is part of the reason when we entered software and came into software, getting customers off of the spreadsheets and into a centralized system of record was a great step, because now you had multi-source data from people contributing, and you didn't have some of the versioning problems, right? So we've got powerful tools, we've got brilliant methodologies, we've got powerful telemetry, yet cyber risk has been difficult to communicate. Why is it so difficult to communicate? Well, years ago, I remember being on calls where I would show the software to large corporations, and they would say, "This is wonderful. This is great. You can associate risk to controls. You can calculate a residual. This is all brilliant." But how do you know what the likelihood is? How do you know what the impacts are? How do you do that? Because if I go into a C-suite or a boardroom and I tell everyone I've just been sort of licking my finger and holding it to the wind, it's not going to fly. It's just not going to fly. So why has cyber risk been difficult to communicate? Well, because everyone sort of brings their own idea of what risk is to some extent, and it hasn't been as data-driven as it can be. So methods of financializing the risk have been methodologically unsound. We're all familiar with NIST's efforts in risk modeling. We're all familiar with the FAIR Institute's efforts. These are all brilliant tools to analyze risk, but you need data, and that's all important. You need to have actual event data, and you need to be able to benchmark across different sectors, different company sizes, and the like, and you need to be able to financialize that. So the last point here is that threat and posture-informed analysis is labor-intensive, point in time, and remains opaque to management. Perhaps it should remain opaque to management, but we need a better way to do threat and posture-informed analysis as well. You look at some of the great open source tools out there. You can visualize nodes all day long. But again, there's not a lot of discernment brought to the problem, because you'll often see a good mapping from something like Lockbit into the TTPs and then into some controls. But then you'll start to see nodes with hashes and nodes with IP addresses. And at that point, you've lost the plot somewhat, because these are machine readable things. They're not, human readable. They're not going to help in the analysis of which remediations should be the ones I prioritize. And you can't do that analysis from a wider lens. You need to be able to do these analyses granularly, and you also need to be able to do them in a wider lens so that you can present your challenges to executives. So, we need to stop bringing a spreadsheet to the knife fight. So what needs to be done? And this is where, some of the AI part of my story comes into play. Look at on the left there, we have some of the multiplicity of regs and standards, right? We all work with them. I was on a call this morning, and I was surprised to hear corporate counsel talking about, NIST 853, but, this is becoming more of a more of a day-to-day thing for all sorts of people in the organization. But what is the long-standing problem over here on the left? Multiplicity of regs and standards, compliance mentality differing from a security mentality, right? And then also, how do I get into a new framework, right? One of the early uses of AI for us was, let's get away from the approach of, say, the UCF or the SEF, which basically breaks control frameworks into little baby atomic components, and then you can walk across any number of standards. Let's train some NLP on all the regulatory standards on the planet and get it predictively, associating controls across standards, not just controls, but into the control actions. So AI has had a lot to contribute here on the left. What is the knot in itself? Well, we all know it. We all deal with the variations of this problem on a day-to-day basis. It's a problem we know intimately, right? It's the proliferation of frameworks combined with the multiplicity of cyber product data types. I've been involved in 2 conversations just in the last 2 weeks where I'm looking at architectures that have over 200 products in the stack, right? How do you get value from that information? You can certainly stay in an individual product's ecosystem and understand the world through the lens of a particular dashboard or a particular product or a particular data type. But then you're just getting more and more specialized. You're not doing the translation that's necessary to use that data at scale. So we have a legendary plate of spaghetti in cyber. We just do. And that's why I'm fascinated with cyber, because translating the data and increasing the data quality and making the data ready for training. So getting that data into the shape it needs to be in for machine learning and AI applications is just really tremendously exciting to me. And we get to do it on a daily basis through some of our control automation projects. And over on the right, what do we have? Well, we've got a lot of brilliant research done by a lot of stalwart individuals. We've got MITRE, we've got FAIR, we've got the vulnerability scoring system, we've got EPSS, we've got Scientia doing their brilliant analyses by sector. We've got, telemetry coming in from all these products, data and data structures. Most of the great open source tooling and analysis has not been related and automated. I've seen some legendary spreadsheets in my time. I've seen spreadsheets with 50,000 lines of code in them, VBA, and they're great. They do a great analysis. You could drop sort of a vector into them and ask the model what you should do in terms of the controls, and there may even be some financial impact analysis embedded in them, but they take 5 minutes to run in a particular analysis, and they're not intuitive either. You don't get to see the data singing. You just don't get to see it. So I think maybe the next slide will just give it. This is just to give a sort of an indication, a little appetizer of what could be in store for our industry in the future. What is a GNN? We all know what a large an LLM is now, thanks to OpenAI. Impressive tooling, but it's not. It's built on some of these architectures. But I'm from a background of more specialist models. You train models for specific types of insights. Large language models can be trained on these things. You can sort of subtrain them on some of this as well. But it's best to have maybe an architecture that's very flexible. And a graph neural net is that architecture. We've been working with them now for about a year. They have a lot of great sort of efficiencies that just come built into them. Relational databases are just a great fit with them. They have sort of a node and edge structure. So much that's unknown can be better approximated. You can learn things from training models like this. You just need to assure some of the data quality. So I'm just going to actually play this video. This only has 8 or 9 data types in it. And I'll just sort of indicate some of the data types that are in here. We've got maybe 2,000 CVEs in here. We've got CAPEC mitigations. We've got all of Rev 5 in here. We've got all of the TTPs in here. So MITRE attack is in here. We've got CAPEC itself, so the actual numbered attack patterns. We've got risk, which is really the 18 vectors we use out of our actuarial data set. We've got Varus in here. The Varus enumerations are parked in here just as a way to kind of get additional data into the model. And then we've got just a smattering of group information. That's some of the analyses that come out of MITRE around the sort of malware variants and TTPs that certain APT groups are using. So I'm just going to play this. This is the model sort of setting itself and discovering distances among these data types. So just let it play. All right. That's just to be illustrative of, how we can get out of spreadsheets. We've all seen the sort of node diagrams. I think that having an appreciation for the complexity of the problem is vitally important. And what we're trying to do is bring more and more of this kind of analysis into this space. The good news about this is once you've established all of the deterministic connections between data types, you can then start automating some of the information like from threat feeds into models like this. You can get analysis on the fly. You can get financial data into it. You can get Monte Carlo type simulations into it. So this can be, on the one hand, an analytical tool to aid in what certain threat scenarios might look like, how you decompose those threat scenarios into, say, Lockbit or Conti, what those look like historically, but also how those roll up, more importantly, to broader exposures that you can then socialize with management and begin to understand what I like to call the efficient frontier of optimization of your program, which is really, what should I privilege? What should I deprivilege? What is the ROI on this project versus that project? That's essential for professionals to secure the budget they need to actually increase resiliency in hardened systems. And that has been pretty elusive. Just going to jump here. I'm playing it again. All right. So how does this flow across the stack? Data, big problem. As I said, horribly balkanized. And when it isn't balkanized, it's not in the formats you need. So there's a lot of taming of data. There's a lot of deciding what taxonomies will look like. You've got to get all this data ready for machine learning. One of the sort of, I wouldn't call it a dirty secret of AI, but it's maybe not all that well known, is there are always human beings conditioning the data and getting it ready for the model. You can't just, you can feed it raw and unstructured stuff, but only after you've taught it what to look for. So it's very important to have the data. It's a long list. There's a lot of data conditioning that goes into this, but it's very exciting because the data, begins to sing. It begins to become useful. It's not lost anymore. It's not lost without a broader context. So agent GNN, I showed you some graph neural net and what they look like. Cyber is a complex web of entities. GNNs are complex webs of entities. New data, how input and output interact. An LLM in this, and I'll get to that, but in this model, an LLM is really that layer you can fold in at the end to interact with a more specialist model. Risk and actuarial models. This has been needlessly controversial in our space, but it's becoming less so, and that's great. A model is just a model. These are ways for us to talk about risks like ransomware, like access and privilege abuse, like physical access to systems, like misconfiguration. There are ways to kind of talk to these vectors, reach into the existing threat stack, start to populate all of those vectors by type, and begin to do some analysis, actuarially speaking. And then have some of the entities and types that we deal with in cyber inherit some of this financialization. all important in explaining what we do to the business. So like I said, LLMs, I think, are ways to engage. You can build a model like the ones we're building and use LLMs to query them. Very important, very intuitive. And LLMs know a lot of things. You can go and you can talk to LLMs about a lot of things in cyber, but it's not going to be able to look at and be as dynamic as we need to be in training specialist models. So at the end of it, what are we looking for? We're looking for models to actually, help us do our day-to-day tasks and tell us things we don't know. When I talk to professionals at large organizations and I ask them what they need, they tell me, quite frankly, we need to know the things we don't know and that we should know. And that is what getting the data into, shape for the training of these specialist models can do. It can begin, to provide insights and correlations into things that we may not have seen previously. It's a very exciting time, I think, in cyber risk management because there are more and more powerful tools coming into it. We're getting out of that flat world, I think, and we're moving into 3 and plus and more dimensions. And in our analyses, and we're also able to build in some financial models, which are just going to help us in the long run. Let me see if I've got any questions here from the panelists. I don't see any at the moment. Well, that is really my presentation on this, and I want to thank you all for attending. If any questions do come over, oh, here we go. What is the next step to operationalizing the Stargate map? That's right. Yeah. The next step to operate the Stargate map is basically getting a single path through, right? Because you've got to step through the Stargate, right, in order to actually travel to another dimension or to another universe. So really navigating single path and simplifying the visuals. What we've done already is those visuals are not so, the nodes are not so white anymore. They're now multicolored, and you can select discrete regions because it's going to be, if you get threat intelligence coming in every day and CISA's catalog expands, and there weren't even assets in that diagram, PJ. You can imagine if you're dealing with tens of thousands of assets, you're dealing with, 250,000 vulnerabilities, you're dealing with threat intelligence reports coming in on a daily basis, you're going to need to select a point in the path and navigate from there, right? So you need to be able to navigate a single path through or multiple paths through. So that's really the next step with Stargate. Yes. How do you communicate this to small and medium businesses, or is this large business activity at the moment? That's a great question. I think in some ways, the R&D is being done by us in large organizations at the moment, but just like we saw 2 years ago, when we were going live with what we call top-down risk, which is basically calling an actuarial data set and letting you enter your company size, your revenue, and then seeing the top cyber loss vectors that have impacted your organization over time. That was something we developed with large organizations, but immediately had an impact in the SMB space because they may not be as mature in terms of their cyber risk programs. The same applies here. You might have a limited attack surface. If you're smaller, you might have less network complexity. You might have less of a footprint in the cloud, but it's just as important for you to socialize what you're doing and to understand the return on investment for your cyber projects. So models like this can adapt to smaller organizations and provide the insights, especially if you interact with them through the LLMs, which make it a lot more intuitive to understand the results of these analyses. Like you'll be able to ask models like this, look, given that I'm in this sector and this is sort of my employee count, tell me what the big threats over the last couple of months look like, and what are some of the things I can do, people and process wise and technology wise, and how do I socialize this in terms of the ROI with my board? That's everybody needs that. Doesn't matter how big or small you are. So really interested to keep going with this and bring it to solution to market. Well, there it is. You can access the top-down risk analysis that I just referenced through the link at the right, and also on our website as well. I want to thank everybody for joining. Want to thank everybody for your continued collaboration. Solving this takes everyone's effort. Really excited to keep going on this, and really excited to see what we have for the rest of the conference as well. So I'll leave it there and let you all go. Great speaking, and hope I run into you all in the future, maybe in the Stargate portal. All right. Thank you. Take care.